Welcome back, ladies and gentlemen. We'll now continue our discussions under the theme of Maritime AI. May we now invite Mr. Roberto Cazzullo, IACS Council Chair, to deliver the introductory remarks. Mr. Cazzullo, please.
Dear friends, authorities, ladies and gentlemen, it is a great pleasure for me being here. I was asked to make a presentation setting the scene on the use of artificial intelligence in the maritime sector, but I will throw away all my notes because the minister and the previous speakers already did a great job to set the scene. So I will ask to give me the slider to move on the slide, but with your permission, I will be in the center and give you some hints about what is the main role of classification societies and the Association of Classification Societies in this scenario that is very challenging for the maritime industry and giving a lot of opportunities. So allow me to be in the center of. Okay, so what I'd like to say, and it's already been said, is that when we consider the last year a moment where from transformation we went to a reinventation from the application of artificial intelligence and the use of artificial intelligence by any of us, because artificial intelligence is on our cell phones as well as it is on our complex systems that are on board. But there are expectations that in just a few years we will have a real revolution coming out from artificial intelligence to all the industry sectors. So we are at a turning point, and that will also impact the maritime sector. And as classification societies, we are interested to contribute to such an innovation, focusing in particular on the safety side, in order to allow that even the early applications of digital technologies are on the safe side, as well as the decarbonization technologies that we are looking for. And we are very pleased to have, as IACS, as an association, an agreement with the MPA here in Singapore to promote these concepts within the industry, being aware that Singapore is a hub of international trades, and it is a very important position in the world for promoting the technologies. The COVID period, in fact, accelerated the digital transformation in the maritime industry, and we are ahead with respect to before the COVID period. As IACS, we, let's say, contributed to that, allowing vessels to trade during the COVID period by carrying out remote surveys. These remote surveys were using a lot of digital technologies to guide the inspectors on board by means of experts that were ashore, and to have a dialogue with communication on one side and the other side. And this sort of remotely assisted surveys, as well as remotely assisted operation in the maritime sector, will become and is becoming a reality. And if we consider the amount of data that is exchanged and consumptions per vessel in gigabytes, just in 1 year, there has been a dramatic increase, and there will be also a dramatic increase in the sort of investments on artificial intelligence solutions in the maritime sector in just a few years, according to some providers of this data. By the way, the slides that you see on the screen are almost all generated by artificial intelligence. We are going in a period where even the most conventional ships will become smart ships, will be ships that will have opportunity of communications from ports or satellites by 5G or satellite communications. They will use blockchain for contractual matters. They will have a benefit of having a digital twin model defined at the construction stage by the shipbuilders, then followed during the operation both by the ship management as well as by classification societies, simulating the behavior of a ship through the digital twin using the digital twin for training purposes. So it is a very powerful tool that we have now in our hands, as said by the speakers before, Greg Wilsons. Internet of Things means a lot of sensors that will be placed on board, and these sensors will transfer data, information ashore. And there is a big difference between the raw data that will come ashore and the data analytics that will carry out in order to derive some important information. And that is a matter where the ownership of data, the transparency of data, the reliability of data provided, as well as the transparencies of the digital tool, the artificial intelligence tool that is used, is very important to rely on the information that will come out from this assessment, as well as for us as classification societies to use this information, as said before, by moving from time-based surveys and inspections to performance-based surveys and inspections, allowing then to increase the productivity and the effectiveness of ship operations. As well as complex systems, we know that ships are more and more automated. The integration of these systems on board is already a challenge. And the fact that most of this data will then be used for being transferred ashore for verifying the ship performance is another challenge. And we, as classification societies and in the Association of Classification Societies, are studying in detail what does it mean a complex system and how can we use the complex system as an opportunity to monitor the performance of the whole vessel, as well as to simplify the information that is given to the crew or given to the shore staff in order to understand what is the performance of a complex system, and arrive at a remote diagnostic that will be a powerful tool to schedule better our work, as well as the ship management work in the operation of vessels. So small ships will become all the conventional ships. But we are also working hard to contribute to the IMO developments on the so-called MAS, the autonomous ships. And here it is really a challenge because we have, as a start, to define what autonomous functions mean. Because we are talking more and more about automated functions that will become more and more autonomous, perhaps with a reduced crew on board, but not touching, let me say, the overriding responsibility of the master to run the vessel, or considering what will be in the future this responsibility with respect to the remote operating center responsibility that will monitor the performance of these vessels as well. There are several challenges from safety point of view, including, for instance, the communication between autonomous vessels and conventional ships, and between the level of responsibility and the ownership of the data that will be derived from autonomous vessels ashore and perhaps go to operating centers ashore. And in my feeling, it means that ships will become more and more closer to aircraft networks today, where in fact the ships will be not alone at sea, but will be constantly linked to operating centers ashore to see the operations, not only for autonomous ships, but as well as also for the interface between autonomous ships and conventional vessels. The digital twin models will become also very important to digitalize the yards, the shipbuilders, because there is a matter of recognition, there is a matter of inventory, there is a matter of health and safety monitoring that is very important for the builders as well. And we would like to promote in our dialogue with the shipbuilders the fact that the shipbuilders become themselves the promoter of the digital technologies, developing the digital twin for the vessels when it is delivered to the owner, as well as having their own digital twin model to simulate the activities on the yard and to optimize most of the activities that are carried out in the yard through augmented reality. This is also a concern for the builders for training. Maritime academies will not only deal with ships in operation, but most probably will also deal with technical staff being employed and all the workers being employed in big shipyards. I don't have to repeat here because the minister and the MPA, everybody presented their great efforts carried out by the Singapore port authorities to become a part of a smart ecosystem. And I think that is most important thing that we can look forward is to consider not ships in isolation, but ships integrated with ports and ports integrated with inland facilities. And that will mean that in respect to the traditional regulations where also for the maritime world, where considering ships and the ship-port interface a little bit separate, we will more and more integrate this information through application of digital technologies that, as I mentioned, will be about communication, will be about digital twins, will be about sensors to monitor the traffic, to optimize the routes, to reduce congestions, to save money, but as well as save pollution, reduce the pollution and carbon emissions because of optimization of all these activities. So we are all becoming part of a very important chain in this respect, and we will make best use about digital technologies to achieve that result. What I'm saying is that the digital transformation, we believe, is not about replacing the human capabilities, but enhancing the human capabilities, reskilling the people that will be on board, reskilling the people that ashore will monitor ships during operation, reskilling also our technical staff, our surveyors, to face the implementation of these new technologies. And for this reason, within IACS, within the associations, we decided to convert a little bit our way of thinking, our cultural way of thinking, to consider the human element at the center of regulatory development and to analyze what could be the engineering technical solutions that would try to reduce the burden for people either being on board or ashore. Reduce the burden could be to reduce paperwork, and of course the use of tools can really reduce or take out the paperwork on board, and will be already a great importance for reskilling persons that are overburdened by a lot of papers to be produced, and as well as to allow that people use simulators and are not exposed themselves directly to a hazard, but they are trained to mitigate the consequence of a hazard or to deal with the hazard during training sessions. And for this reason, we as IACS are very proud of being part of the agreement that we signed yesterday with the MPA about the training facilities that will be provided here in Singapore, as well as we are promoting similar initiatives all over the world, because the human element is at the center of any activity that is related both to digitalization and decarbonization. The reason of our interest in that move forward, the fact of moving from expert groups that we have in our organizations that, for instance, discussed the cyber resilience and developed harmonized, unified requirements for cyber resilience of ships and the ships in delivery when they are delivered by the builders, as well as we had an expert group, and we have an expert groups contributing to the work of IMO on autonomous ships. As I mentioned, we are dealing with complex systems. We would like to work more on the standardization of digital twin models for different ship types and ship operations. We are improving our survey requirements, as mentioned before, based on condition monitoring, based on sensors that will provide the data ashore, as well as we are working a lot on the human element. For this reason, we decided to upgrade this work and establish a new, we call it Safe Digital Transformation Panel, that will provide the expertise coming from all the 12 classification societies that are member of the association today, and putting the best for the best at disposal of the administrations, at disposal of the industry, to promote the implementation of digital technologies in the maritime sectors. I just finished with that, and probably during the open discussion we might take some of these elements for an open discussion. There are challenges that will become opportunities. The data analytics is certainly a challenge when we get or will get a lot of big data, and the challenge is also the analysis of this data to derive important information. And this is a challenge that we will resolve in terms of becoming an opportunity. And taking that as an opportunity also for improving the standardization of information that is provided in order to allow that when there is, for instance, a transfer of flag, a transfer of class, a transfer of ship ownership, there is not a lack of continuity in this analysis of information, because we are working for the life cycle of the vessels. There is an important matter about the data ownership, and we believe that the owners of the vessels are the ones that are the owners of the data that are provided. And then we'll open then an issue about the cooperation, the communication of information derived from this data to the benefit of the whole industry, how to neutralize the data, how to analyze the data in order to provide useful information for the benefit of the whole industry and give accessibility to this data. It's certainly a challenge, and we will resolve this challenge in order to give an opportunity, as well as the protection of data from cyber attacks or for misuse of data or for weaknesses in the systems and the automation systems that would allow to have open doors to damage this data. So the fact of developing and further developing criteria on cyber resilience and criteria that are relating to the safety management, considering cyber as a risk, are for us very important, and we will contribute to that as an association and as individual classification societies. And in all this respect, there is also an element about the cost of energy, because we got, for instance, an information that the cost of some information centers is like the cost of energy in Switzerland every year. So the use of these technologies will require also an optimization of the networks, the clouds, and all these things, because in the maritime sector, we will use very, very big amounts of data, and that will have also an impact from the energy point of view. And of course, there is an element of communication, because there is also a matter that is very important about cooperation of all interest stakeholders to promote these developments. So thanks you for your attention. I hope that I have not bothered you about what we do. We believe that in this period of transformations and let's say a sort of turbulence, the greatest dangers in these times of turbulence is not the turbulence, because the turbulence is an opportunity, is to act with the yesterday logic. And that is true. We have to adopt, and also ourselves that are very old guys, we started 300 centuries ago to dealing with this job, we have to face these opportunities with a future logic and not with the yesterday logic. Thank you very much for your attention.
Thank you, Mr. Cazzullo. Please remain on stage. Ladies and gentlemen, we'll be having a Q&A later on, and to post your questions, you can kindly scan the QR code you see on the screen. May we now invite Dr. Su Yi, Executive Director, Institute of High Performance Computing, Agency for Science, Technology and Research, A*STAR, to deliver his presentation on Empower Maritime Digital Transformation with Artificial Intelligence. Dr. Su, please.
Good morning. My name is Sui. I'm from the Agency for Science, Technology and Research. This is the Singapore's agency that manages R&D in Singapore with a focus on translation for economic and societal impact. I'm from one of the institute in A-Star called the Institute of High Performance Computing. And over the years, we have the privilege of hosting a national initiative called the Maritime AI program. And this program, as the name implies, focuses on building maritime innovation with a focus of translating some of this innovation to impact our maritime sector. Now, in my presentation today, I will cover the following. I will start with sharing of some context in the AI and digitalization space for the maritime sector. Next, I will cover a little brief about the Maritime AI Research Program in Singapore. And half of the presentation will focus on illustrating some of the use cases and showing how AI could be translated and how it could benefit the sector. And lastly, to acknowledge some of my ecosystem partners and stakeholders. So a simple presentation. So starting with some background information to frame today's discussion, if we look at the trends, the market trends, if we look at the graph, the bar charts on the left-hand side, you'll see that by 2028, the maritime digitalization and AI market would exceed 260 billion in terms of value. What is driving this market? What is driving this? If you look at the pie chart, the three biggest segments that is driving this are the ports and terminals, because there's a lot of operations, issues around efficiency, a lot of need around automation. Shipping companies that is focused on transportation, maritime freight forwarders that looks primarily at issues around logistics, where AI, digitalization, and analytics have huge opportunity for application. Now, according to Lloyd's Register and TTS reports, in the sub-segment of AI-driven systems and vessel autonomy, this is approximated to reach 5 billion by 2028. And if we narrow down on the AI sliver or segment of this technology port, we could see a few potential areas of application of AI. Firstly, and very importantly, is in maritime safety and security. Secondly, in predictive maintenance, which is used both by shippers, by ports and terminals. Decarbonization is a huge topic, and we hear this being repeated many times by Minister, by Roberto, and this is an important topic that digitalization has a huge role to play to achieve decarb and net zero by 2050. The examples on the right-hand side, be it in autonomous shipping, in using robotics for maritime applications, or smart ports, which has already been talked about, the whole focus is about improving efficiency. And some might also argue that using AI to augment human attention, this could enhance safety as well, and overall improving the competitiveness of the business. So AI could be used to drive many benefits in the sector. Now, zooming down to Singapore, why is this important? And these are some statistics that you can see here. Last year in 2023, our annual throughput in terms of vessels have exceeded 3.9 billion GT. Okay, so this was an almost 10% increase from the previous review. And in terms of the TEU's throughput, it has increased to 39 million, and that is a 4 to 5% increase. And not to mention that there's an increase in sale of bunkering fuels. So for those of us who might not be very familiar with the evolution in the Singapore maritime sector and the ports, what is happening over time is that we are consolidating all our port activities to the western end of the island into a mega port called the Tuas Mega Port. So when that shift actually happens, and which is already happening, the throughput that we are we are targeting to achieve is 65, if I recall correctly, there's 65 million TEUs. And with so many ships consolidated into one part of the island, concentrated at one location, how are we going to achieve efficiency? How are we going to maintain safety with zero accident? How are we going to achieve our decarbonization goals? And in this context, part of the answer to this big question is to use the digitalization and to use AI in appropriate ways. Now, it was almost 1 year or slightly more than 1 year ago where we conducted a workshop in consultant with many of our partners. And in this workshop, I recall there's more than 80 companies that joined us with a focused discussion around what are the challenges in AI and how do we put that technology into use. Now, while we talk about all the promises in AI, we know that the technology insertion is not a straightforward process. And in consolidating all the challenges, we came up with 4 things that we need to pay a lot of attention to. And the first is about data silos. The maritime sector is complex. There are many companies involved. Data resides with many owners. How do we break down the data silos? How do we share data effectively? How do we ensure the quality of data? Number 2, challenges in ease of use of AI models, and that has to go in tandem with talent development, training a workforce that is familiar with use of modern technology. How do we scale the solution? How do we scale AI that's now getting bigger and bigger? They are now more compute intensive. How do we balance the energy use of AI and yet achieve the decarbonization effect of digitalization? So that is the third challenge. And in many of the AI applications, especially in autonomous vessels, autonomous equipments in the ports, how do we ensure that the AI is trustable? So these are some of the challenges that the industry sector has floated up. And these are some of the problems that we want to solve through the Maritime AI program in Singapore. So how are we doing that? This slide shows the foundation that we're building. So before even talking about application of AI, we need to focus on building the strong foundation. And in terms of strong foundation, the first is on data. No, we hear today at the keynote about big data, huge data. But it is not just about the size of the data. It is also about the quality of the data. So if the data is not clean, if the data is not good, big data means bigger problems. Huge data means even bigger problems. So we need to address the question about data quality, and part of our effort in the Maritime AI program is to build tool chains and toolkits to accelerate the cleaning of data, to make sure that the data is of high quality before we put that into the repository for use, which could benefit downstream AI application. And in addition to data, the next focus is on model excellence, which is in terms of how we build the models, how it can be robust, how it could be fully tested, trustable, and in some cases, how to make them explainable. So our aim is to build that base platform. And with this base platform, we could then focus on the center blue circle that you see there called the Maritime Applied Solutions. Because AI, our view is that AI is not the one and only tool to solve all problems. AI is part of the technological solution that could be inserted into the workflow, into the full system, into the full scheme of things to deliver a solution. And in our focus of building applied solutions, we look at 3 big categories. The first is on port efficiency. Secondly, on enhancing vessel traffic safety in our waters. And thirdly, of course, on decarbonization. So over the last 8 years, we have worked with multiple industry partners and built a list of technology and IP under this program. I will use the next half of my presentation to illustrate some of the usage or some of the AI technology insertion into our work. And today's discussion is primarily around movement of vessels end to end. So a lot of these illustration examples I'm going to share later on is about route optimization, about how do we achieve decarbonization objectives through all this optimization effort. So the picture here, the illustration here shows the movement or the transit of a vessel through time. So if you start with number one, this is where the vessel is very far out from the port, 3 days plus ahead of time, we could do prediction of ETA and adjust the operations on the ship and achieve JIT. As the vessel gets closer to the port, 1 to 2 hours out, we could predict the arrival time to the pilot boarding station, and 30 minutes out, we could even estimate where would hotspots be forming near our port waters, and 10 to 15 minutes ahead, we could have that window to detect near miss, to detect potential collision in the busy port waters. And to augment all this, there's also a slew of port services like tugboats, like hovercrafts that is plowing our waters. So we need to also integrate these operations to look at this system as a whole, right? So it's to look at global traffic, to synergize all the information and insights for overall intelligence and to enable situational awareness for our port waters. For some of these, there's already ongoing trials to test the robustness of the AI and to show the utility and to show the benefits. There are also upcoming trials that we are planning together with our stakeholders and partners on prediction on the JIT aspect, as well as the fuel consumption optimization for some of our port services. Now, in the first example is an example on just-in-time operations and how we apply AI for this. I will play the video. There's supposed to be sound from the video.
Conditions like waves, wind and current, impact on fuel consumption rates along the navigation path. While the dashboard helps fleet operation managers facilitate the JIT arrival of individual ships.
Okay, I think this is a short snippet from the video, but what this video shows is that we use a few layers of information to build into this JIT decision-making and optimization. Number one, we take information from the port situation, for example, availability of the berth and how congested the port is. Secondly, we make use of met-ocean information, looking at the environmental factors that could affect the movement of the ships vis-a-vis fuel consumption. And when we put all these different layers of information together, we could then estimate the arrival of the ship, and then we could also in turn advise the vessel operator to say that perhaps at some point you could go slower, you could use slow steaming to save fuel so that when you arrive at the port, you do not have to wait so long. So this whole idea of using multiple layers of information and data, applying AI, modeling and simulation into the system could allow us to achieve a JIT effect. So what is the benefit? Quantifiably, we think that with this, we could at least achieve more than 10% reduction in terms of fuel consumption. In terms of unnecessary wait time, we could save up to 5 hours. So this is based on simulated data. So with an ongoing trial, we could then validate some of these expectations and claims. In the next example, it is actually a prototype on predictive safety management. In the video that you're going to see, there is 2 panels. The panel on the left shows conventional vessel traffic management system. The panel on the right shows what you are building.
By harnessing near-miss case detection and collision risk assessment capabilities, the team developed an enhanced risk warning alert feature, which predicts turning trajectories, giving operators alerts 6 to 7 minutes earlier than traditional pairwise vessel trajectory warnings. To cater to the high traffic density in Singapore port waters, the pairwise vessel collision detection and alert have been further enhanced to enable multi-vessel encounter situation detection and prediction. This allows earlier warnings to be sent up to 10 to 15 minutes ahead. Proactive traffic management algorithms are necessary to provide insights into the dynamic traffic conditions in the Singapore street.
So in this short extract of the video, what we are trying to show is that this system is able to predict near miss or collision kind of information of situation in our port waters 10 to 15 minutes ahead of time. So that gives enough time for the port operators to alert the vessel owner to prevent situation like this. So in terms of traffic hotspot detection, it could be predicted up to 30 minutes ahead of time. For other more risky encounter like near misses and collision risk, it could be predicted 10 to 15 minutes. Now this is a zoom in of what we could see. So this arrow is pointing at the hotspot formation. So that is 30 minutes ahead of time. The red squares here indicate vessels that will be involved in the hotspot. So at this point, 30 minutes ahead of time, they are not within the hotspot yet. So in 30 minutes time, they will all be congested within those regions. And this arrow is pointing to a particular vessel that is coming into the hotspot, but with a lot of crossings with other vessels. So there is a potential of near misses, a potential of collision. And this is a situation that we are trying to avoid. Now, in this next example is an example of how we use AI for fuel saving by better planning of routing of all our hovercrafts and tugboats. So, as I'm running out of time, I'll go a bit fast on this. Key to this is good data. So that is the foundation. With good data, then we could apply the familiar framework that many of you might already know, called the DPP framework on data analytics. Firstly, using descriptive analytics. The aim is to understand the route pattern of the ship with understanding of the fuel consumption pattern, its transit mode, whether it's idling, whether it's transit, whether it is tugging or towing. With understanding of those behavior, we could then use predictive AI to estimate what might happen in the future, and then eventually to use prescription to optimize the operations. So that is for all the port services that is plowing our waters today. Now, what is an AI presentation without mentioning LLMs? So we are also exploring the use of LLMs, because while we build up data sets, while we build up AI models, it's going to get a bit difficult to manage over time because there's so many options. And the LLM here is a showcase of how we could use that to guide potential users to search the repository, to search the huge library of data sets and AI in order to know what is usable, how they could apply AI or AI models to some of their application. You might not be able to see this quite clearly, but the user is prompting the LLM to say that what are some of the AI models that could be used to predict birth stay? And the AI replied to say that, oh, there are 3 options here. There's the birth net, dog net, stay net. And then the user could go ahead and further prompt it and say that for birth net, could you tell me what is the input necessary to the data? The AI could interact with the user in a very natural way. And using an LLM like this, we think that it could help accelerate the development of AI and help us do knowledge management over time. So this is a work that has just started, and we are now at version 0.1. Now, I want to spend the last 30 seconds to acknowledge all our partners who have onboarded with us for this journey. We have today 10 industry partners on board the Maritime AI program, and we would like to really show our gratitude to the Maritime Port Authority and the Singapore Maritime Institute for sponsoring, for funding, and for providing the guidance to the program, and for all my colleagues who are serving on the steering column to guide the program along. This is the group of very talented researchers who have contributed to all the demos that you have seen in the slide deck. I would like to point out Dr. Fu Xiuqi at the bottom there, the program director who has provided great technical leadership to the team, the project managers who have helped to shepherd the program forward, and to all the technical contribution of all these talented people. With that, I thank you.
Thank you, Dr. Su. Kindly remain on stage. Ladies and gentlemen, we'll be having a Q&A later on, and to pose your questions, please scan the QR code on the screen. May we now invite Mr. No Kyung-soo, Chief Operating Officer, Seadronics Corp of Korea, to deliver his presentation on remote pilotage. Mr. No, please.
Hello, everyone. My name is Kyung-soo No. I'm the Chief Operating Officer at Seadronics. Seadronics has been developing AI for autonomous vessel more than 8 years. I think thanks to Mr. Roberto Cazzillo and Dr. Sue Wee that give us a very good overview of the AI and how AI can transform in maritime industries. So today, I'm going to explain more details about the actual operational references, what Seadronics has been developed using our AI, and also how this technology can affect into the remote pilotages, and also the several definitions of the situation awarenesses, what IMO has been defined recently. So this might be the very typical images when you hear about the remote pilotages. Yes, there might be the virtual operating centers that you can have all the information from the vessels, and also this information can be connected with the 5Gs or the low orbit satellite internet, such as Starlinks. So this is very popular that everyone can guess, oh, this is really super amazing. Then if it is possible, yes, definitely we can reduce all the burdens of the human behaviors. And yes, you can be safely assisting all the navigations and we will increase all the efficiencies. Yes, I really agree with Roberto's saying that AI is assisting human behavior, not replacing at this moment. But at the real time, in real world, this would be a little bit difficult to actualize this virtual controlling center since you don't have enough situation information for now. This is the typical berthing situations. Even the experienced pilots on boards and tugboats are assisting these things, but all the navigators should be at the bridge wings and watching with their naked eyes, where it depends on the human experiences. Unlike ocean area, the nearshore area, or the congested port like in Singapore, all the process is still the manual and highly depends on the human experiences. So let's talk about the autonomy level here. This is academically defined that the recognition is the key things that we should solve to automate all the navigations and turning into the remote pilotage or ultimately the autonomous vessels. However, even though we are assisting by the radar or ADDC, any other smart solutions, still it might require a lot of human interpretations. For example, radar has so many noises, so only the experienced navigators can interpret it. So even though if you have a very nice virtual controlling center at the offices and these experienced navigators is not on board, all the processes will become confusions and it may cause a lot of accidents. But what if you have this information that from the existing sensors, we're adding more sensors, and AI can generate a better situation information. And what if it gives you the right optimized route planning or how to avoid collisions? So the only humans can decide whether to follow these directions or follow these recommendations. This is what Seadronics is thinking that, oh, this will be the very first requirement to achieve in advance if we want to actualize remote pilotage. So this is not just a prototype at all. This is the examples what Seadronics has been developed and already commercialized in Korea. For example, Port of Busan or major shipping carriers or even tugboats. So imagine if you have 360-degree views around the vessels, then you can use this information when you navigate it. And also, we provide you the real-time object recognitions immediately from the videos, also providing you the distant measurements of the detected objects. The tugboat has the views, and also even for the port operators, we're providing the approaching speed of the berthing vessels and also the remaining distance. all of this information will increase your situational awareness informations thanks to the AI. And we are now developing this into that integrated all the individual information from the vessels or from the ports or even from other existing radar data or ADDCs. All this information can be combined into your virtual controlling center. Then I would say the man who experienced navigator should only decide whether to follow this information, whether to decide which way to control. And ultimately, if this AI situational awarenesses will exceeding the human capabilities in some point, yes, we would say that is the autonomous vessel in the future. However, for now, there might be sort of the pros and cons in this AI and still require certain level of the performances. However, this is the actual references we have proved that AI can apply it into actual maritime industry, then assisting your safe navigation, also optimize your whole operations, especially when you're getting into the congested port area. And one thing you should remember is that AI should be on board and process it on the edges. Because if you imagine, AI requires tons of server, and if you decided to run this AI on the cloud server, yes, the total amount of data should be transferred, and it takes a lot of time. Even 1 or 2 seconds delay, it may cause a lot of catastrophic accidents on your operations. So what Sedronics always consider is very light versions of the AI, but has better performances of detecting the objects accurately and try to reduce all the latency issues. So only the essential information has been processed on the vessels will be transmitted to via the internet. It could be 4G, 5G, whatever is low orbit satellite internet. So it could be safely protected the core data from the cyber attack. Also, you don't have to pay any operational costs using a very expensive GPU server clouds. So please remember, all of this AI should be at the vessels that can be processed perfectly, that assisting your remote pilotage, also ultimately to the autonomous vessels. So I brought some provisions that IMO has defined what is the situational awarenesses under the MAS code, which is the Maritime Autonomous Surface Ships Regulations and Standard, which already has been released as a draft. So all of the vessels should apply this kind of new sensor system that can be adaptively matched with the situational awareness informations voluntarily from 2026 and also mandatory from 2028. So this has been divided into 4 steps. I think IMO has considered the very experienced navigator abilities that can have the full situational awareness around when you navigate. However, detection, recognition, identification function can be fulfilled using existing smart devices and also adding on our AI. Also, to the lookout functions, maybe not 100% replacing the human abilities, but at a certain point, we can definitely assisting their whole operations. So this is the examples of our suggestions, Sedronic suggestions on the sensor systems. So still, a lot of vessels already adopt AIS and ACTIS, and also our radar, but AI can help this, eliminating all the noises and giving you a better understanding of the situational awarenesses. Also, the camera with our AI-generated image recognitions, so it gives you a better situational awarenesses. And also, like automotive industries, that we're suggesting to putting on the LiDAR, which is the 3D laser sensors, then you can create the local maps that gives you a 3D, very clear maps around the ship navigating situations. So not 100%, but if you add on and fuse different data into one, that you can create a complete situational awareness formations that lead you to the remote pilotage as well as autonomous vessel in the future. So this is how Sedronics has applied our core technologies. From the video that we can clearly understand what is the vessels, what is the land area, and what are the ocean area. And we can classify each object like this very clearly, not detecting the rectangle area, but very clear size in the pixel level that we can put more emphasis on the ships, small vessel, or even buoys, sea area, ground area. Also, based on this information, we can give you very accurate distance measurements just using videos. And to develop these things just using LiDAR, this one is the experimental that we have done in Korea that successfully gives all the situation information and guide the vessel, just follow our directions. Then we have successfully launched this auto-berthing features. This was an experimental area. However, this is the proof that autonomy will come in the near future. So this is the examples of how we see from the video and AI recognitions, and also the radar that recognized by the AI, no need the human interpretations, and also the LiDAR created the 3D local maps. So fusing into this, this is the general map that you can see anywhere, but we are overlaying all the situation information into one, then try to generate what is the optimized routes, how to avoid collisions, how to move this optimized routes that you can find the efficient way. So this is the examples of the total situation awarenesses generated by AI that would be applied into our AI-enabled solutions that highly assisting the navigations, also the port managements. So this is the actual video demonstrations that we have done using our sensor module. And also, we have downloaded just a general navigation situation from the YouTubes, but just applied our AI model. This is the examples. But this accurately recognizes objects perfectly. So this would be the very basic step to increase your recognition level. So this is
advanced AI technology automatically recognizes and analyzes the positions of nearby vessels, buoys, and other maritime objects. It provides real-time situational information, including accurate distances between recognized objects and the vessel. Navis assists safe and efficient navigation in high risk of accident waters, such as congested ports, coastal areas, and narrow channels. Port to port, leading AI company, Seadronics.
So this was the AI-enabled solution, what we have already provided to the ship owners or port operators or even ship management. All the thing is always possible. So I would like to let you know that remote pilotage is not far away. It's right next to us. If you're using AI and if you gather tons of data like us, more than 8 years. However, AI is now in the real world, and we can develop furthermore to assisting the human capabilities and also to the autonomous vessels in the near future. So if you need more detailed information from our Seadronics, you can always come to our booth at the expo, or you can access our website. And there is a more detailed video on the YouTube, so you can have more better informations. And it's very honored to be here, sharing our recent achievements. And also, all of you here will follow the directions that fulfilling the self-autonomous vessel for this maritime industry, safer and smarter way. Thank you very much.
Thank you, Mr. No. Kindly remain on stage. We'll be having a Q&A later on, and to post your questions, please scan the QR code on the screen. May we now invite Mr. Erik de Koren, Chief Executive Officer, co-founder Seabus of Norway, to deliver his presentation on sensors and autonomous ships. Mr. Erik, please.
Hello. Thank you for having me here today. It's an honor to be here at the Singapore Maritime Week to talk also about our company, Seabus. We are from Norway. We're coming out of the Norwegian Technical University in Trondheim. And what we do is we make maritime autonomy software and solutions. We're founded in 2019, and we're based on decades of research that was done with industry all over the world. We have a very strong technical backbone, and what I'll introduce you to today is how maritime autonomy is already creating business opportunities for many, and how maritime autonomy can give value to your business already now. So just first, a question. What are some of the biggest challenges of maritime today? There are quite a few, so let me just bring some of them to you that we believe are important. For instance, inefficient crewing, lack of new recruitment, an aging workforce. We see those problems everywhere. Cost of decarbonization, cost of digitalization, scalability of some business segments. There are many here and many more, and we believe all of these are really important, and they're also slowing down innovation in maritime all over. So what we are proposing here is that maritime autonomy can mitigate all of these in different ways. And I'll show you now how this will create business opportunities for you, and in many different ways. But first of all, I would also like to ask another question. What is autonomy actually doing for different ships? And one of the biggest misconceptions we meet all over the world is that autonomy is perceived as being like unmanned or uncrewed. And actually, it's really far from the truth. You know, there are autonomous vessels out there today, small unmanned surface vessels that do different things. They are unmanned. But for maritime operations, maybe the uncrewed or unmanned vessel is not really what we see as the future. It's so many different things. Autonomy is a ladder with many steps. And some of the values of autonomy can already be realized right now. So, autonomy can add significant value to maritime operations through safety. It makes it leaner. It makes it greener. On the safety side, we are giving enhanced situational awareness, like we just saw from Seadronics, an excellent view on how that is done. We can give collision alerts, we can avoid incidents, and we can assist routine tasks from lookouts. When it comes to making operations leaner, we can optimize the onboard crew composition. The cost of crew can be reduced by reducing the number of crew, or even changing the composition of the certificates required on board for the operations, because autonomy does more of the, let's say, dirty, dull, and dangerous work on board. Cost of accidents also makes operations leaner if you can reduce those, and in general, increase route efficiency, like we saw earlier from Singapore Port. When regarding greener operations, slow steaming is probably one of the more interesting parts here, especially when you're talking about electrifying more vessels. Slow speed is probably the most important range extender for those type of vessels, and autonomy can then take over more of the control for a slow-moving vessel, and the crew can do other things while it does the slow steaming. It's an excellent way of using autonomy right away. And also, because of those cost savings you see here, autonomy is actually acting like an accelerator for green technology, because green technologies on board ships is typically expensive. It takes time to implement, but if you combine that with autonomy, you will have bridge the gap of the cost. So, how does autonomy work? Well, we've seen some examples. We're working with this vessel here in Singapore. I'll show you a little bit more about that. But we have equipped vessels with the radar, LiDAR, AIS, and camera. Well, radar and AIS is typically on board from before, and we add the LiDAR and camera and an onboard computer. And through sensor fusion, we consolidate all of that data into a situational awareness picture. So, well, sensor fusion is generally seen as the most difficult and also important part of autonomy. And this is also where Cebus has its strongest side. And then we're testing this out in many different areas right now. And what we're doing with this vessel is to create one single situational awareness interface that shows collision alerts and potential incidents into the future that the captains then can navigate according to. So the maritime operations or maritime autonomy allows vessels to sense, to comprehend, and plan, and then act, and then actually also very important, supervise the vessel's operations, not just the navigation part, but also be able to see inside the vessel and see how I'm actually doing. What is the battery capacity? Is everything working as it should? Can I actually conduct the operation according to the plan? So that side of the autonomy is equally important to the navigation, actually. And inside all of this, we also use AI to learn from experiences and for reinforcement learning, for object detection. And all of this is actually then being now implemented in different areas. And if everything works okay here, I'll show a video here of how we launched the world's first autonomous commercial passenger vessel in Stockholm. I was hoping to show a video right there. It's not here. It's not a video part of the presentation? Sorry. Okay, that's too bad. All right, I'll show a picture of it at least. Now with some Christmas lights even. The point was that this vessel, we call it MF Estelle, after a Swedish princess. It runs across the water here in Stockholm 100 times a day, fully autonomous. It has no interaction of the onboard captain, which needs to be there because regulatory reasons requires to do so. But only in a couple of weeks, we will actually demonstrate, together with Swedish authorities, operation of this vessel, fully autonomous, without the captain on board, and with passengers. So what the Swedish authorities are saying to us here is that they trust us to do safe navigation, but they're not so sure yet about safe passenger handling being done with this autonomous system. So they require still a safety operator on board. And maybe that's the future, actually, of this type of urban mobility on water going autonomous, is that autonomy replaces the need for a captain, but you need a safety operator. But you have solved so many problems with that transition because captains running these type of vessels are in hard supply. This is a typical dull operation that is hard to find captains to do, and they're more expensive. So our plan here is to have networks of these vessels, and we will do so in Stockholm over the next couple of years. We will have 2 more vessels, and then this will be supervised from a responsible captain from shore. And that is a scalable, lean and green and safe urban mobility solution for the waterways in cities all over the world. And that's also what gave the name to Zebus, because this is the ultimate use case for maritime autonomy as we see it. This is where it can have a tremendous impact on city development and through urban mobility. So here in Singapore, we're working with Yinsun Green Tech. And we've outfitted this electric harbor craft with our autonomous solutions. So what you see here is the interface of a product we call Sea-Watch. It's sort of the first step towards autonomy that gives advice to the crew on board. This is the first step towards a higher level of autonomy, where actually then you will have advanced driver assistance, where the captain doesn't actually have to touch the wheel anymore, and the vessel will then follow the suggested path by the system. So this is what we're doing now, and we're showcasing this week. So please see in the agenda or the program for Singapore Maritime Week for the launch and the demonstration of this vessel later this week. We're also outfitting another vessel for Yinsun. It's called the Hydroglider. This is a foiling vessel, and we are currently in test mode for this, and it will be launched sometime later, and this is for crew transfer. Higher speeds, higher risks for collisions, and also maybe higher need for help with lookouts from autonomy. So, important part of the autonomy software that we have with Zebus is that it's modular and very easily to integrate with other systems. We are adding our system on top of control systems. We are working with different vendors of control systems, and hence can work with many more. And I'll just show you now some examples of vessels that we are working with in different parts. And one is car ferries. This one typically goes back and forth. And here we can help with fuel efficiency, crew optimization, and collision avoidance. The last one actually being a huge problem in this industry. There's a lot of collisions in the docks. We can also follow different regulations and turn car ferries into what they call virtual cable ferries, which essentially means that you don't need seafarers on board. So this is a more like land-based fixed vessel that with autonomy can replace the cable. Workboats, well, here again, safety, crew optimization, and slow steaming for letting the crew do different things while in transit. Short sea shipping, increased safety, energy savings from slow steaming, and crew optimization, already being tested out with customers we're working with. Inland waterway transport is an enormous interest area in the European Union because there's so many waterways that are unused, and autonomy is seen as the enabler to get this type of transportation mode back into business. Now that the typical family businesses of this industry is deteriorating. Water shuttles, well, these are typically simple operations too that can be optimized in terms of crew. Getting back to other value propositions of autonomy: safer, leaner, and greener. Enhanced situational awareness will help ships reduce cost. You can cut costs through optimization of crew and operations, and slow steaming will make green affordable. To sum it all up, autonomy brings unprecedented business opportunities and scalability to the maritime industry. So, Zebus, we're focusing on the software to make this possible. We're working with industry leaders, Yinsun Green Tech here in Singapore, Damen Shipyards out of the Netherlands is providing business to us from all over the world. DNV, our renowned classification society from Norway, is embracing what we do, and we're teaching each other how to certify maritime autonomy going forward. We're already just begun. This is just a start, and the opportunities are immense. We're looking to partner with other industrial partners and investors. So please get in touch afterwards, and we can make history together. Thank you so much.
Thank you, Mr. Eric. Kindly remain on stage. We now have a session that has an interactive online Q&A. To post your questions, please scan the QR code on the screen. Without further ado, I'll now be passing on the time to the session moderator, Dr. Su Yi. Over to you, please.
Thank you. I noticed that we have overrun a little. Our session is supposed to end at 11:45. Do we have a little bit more time from the organizers? Okay, perhaps okay, so the timer is counting down. It's like a bomb, so it's quite scary. I would like to perhaps start by asking a question to Roberto, because we are all building technologies right here, the three of us. From a class society point of view, what would be your advice to people who are building AI technologies with the aim to get it into the industry, into application, get it qualified and certified by class societies? What would be something that you would advise that you would give to us?
I think that the implementation of AI technology is very powerful. And we have to make possible that we apply this, and the AI technology is learning from experience, but avoiding that the first case is an accident. So the recommendation that we always make is that we carry out in a risk assessment, we carry out analysis of personal behavior, people behavior, hazard techniques, and so on, in order to anticipate possible hazards and use the best for artificial intelligence technologies to prevent these hazards. For instance, we are discussing application of alternative fuels like ammonia, that we know it is toxic. The application of the techniques can really prevent people exposures to hazard if well designed.
Yeah. So thank you very much. So perhaps a takeaway for us is then to understand this as a more comprehensive context, meaning that it's not just the due diligence in the utility of the technology, but when it is put into the ecosystem and the environment where human is interacting with it, how do we do proper risk assessment? How do we mitigate to ensure that all these are safe?
Yes, if I can. We have to put people in the center. And when people are in the center, the technologies that are provided become very powerful.
Thank you very much. So perhaps we start with the first question that has the highest vote for autonomous ships. Is IACS, so this is a question again for Roberto. Somehow the question disappeared. Okay, so for autonomous ship, is IACS working on standardizing minimum performance requirements? Could you share some details about the approach? So perhaps I will invite Roberto to start. And since this is on autonomous ships, and perhaps Yongsu and Eric could also chime in on some of these aspects.
Well, perhaps Eric can answer better than me on this question. What I think it is in the Eric presentation that is very important is that it is not true that autonomous functions means unmanned vessel, at least in this transition. And I think the autonomous function can really help in managing the vessels to the point that is required. And so the implementation of the IMO code on autonomous vessels is more now focusing on what is the definition of autonomous functions that are creating these opportunities.
Any other comments from the panelists?
It's actually a very good question because it's difficult to answer. Minimum performance requirements would probably be that the vessel just goes back and forth and does what it's supposed to do and without any incidents. But this is a question we've been working on. So what is a minimum viable product for an autonomous vessel? How can we demonstrate this on a sort of a pilot prototype level? And but the difficult parts are actually the edge cases. Those things that you sort of couldn't really foresee happening, and the vessel can actually still behave safely around those. So I think you need to stress test the system a little bit before you can say that it has met a minimum performance requirement. We do that through simulators. So we do that on any geographical location in the world. We can do that. And I think that is, yeah, I would say that you need to stress test it before you know that it actually works. But how to define it? I think only through testing, not as a performance requirement on the paper, if you see what I'm saying.
So to follow up on that, since I'm a Singaporean, so I'm very interested in the hydro mover project that you mentioned. So in that particular instance, what would be the performance metrics that you will be looking at when it is put on trial in the Singapore waters?
Yeah, that would be when we test this, that it actually detects all the objects that are of importance, cancels out false positives, and actually finds, these are happening too, and then is actually be able to navigate around without the captain's interference. You can actually then, I think the best performance indicator is the trust by the captains on board, that they start to trust the system. Not us, them.
Them, yeah.
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 Do you want to add on?
Yeah, I would like to add on these things because, whenever we try to introduce this AI-enabled solutions, everyone first question is, what is the performances of your AI? What is the accuracies of the recognitions? But in this maritime industry, that, as I mentioned, that it's all depends on the human capabilities, but we don't have any ground truths in this industry yet. So I think the first step is how to prove this is working and what is the current status and how do we competing, to whom we're competing with. So what Citron is preparing for now is we try to open our own benchmark data. Maybe that could be one of the ground truth. Then we try to compete ourselves that at least we are exceeding this certain type of the ground truths or the benchmark data. So try to make all the people understand this is working. This is the certain number of the performances. So I think that would be the number one step, that we should agree a certain level of the benchmark data which can be adaptively matched with the human capabilities.
So do you think that the industry will evolve by perhaps through transitioning from perhaps a level 3 autonomy to level 4 to level 5 over, say, a longer period of time in order to let the human user gain trust in the system, to learn how to coexist with technologies like this? Would that be, would you see that this might be a route that we will take?
I think fully autonomous vessel would be a little bit difficult, and as the automotive industry already shown, that the fully automated is very difficult because it apply to the philosophy. So if there's any 100% accident will occur, but to whom you're going to hit? It could be a old person or a young person. That kind of thing always occurred in front of to fully automated. However, in the ocean area, I think we already have very good functions of the autopilot functions. But what we consider is in the congested port area that gives a more better ideas using AI. So in certain point, yes, definitely, I think this is more like a combinations of the process with the human and AI. But this is the digital transformation that we should create a different standard and different procedures to adaptively operate efficiently. So I think that is the very important things. How do we change our standard? Because this maritime industry has been last more than 100 years using the same procedure. So yeah, I think that would be the key things that we should consider first.
So there's a question that is highly voted, and I see that it's trending. It's actually directed to you, Yong-Soo. I think it's a difficult question, but let's try. The question is, would you say that using your AI solution, you could have avoided the Baltimore incident? And if so, how?
Yes, recently a lot of people ask me about the Baltimore accidents, but as far as I know, this accident is a little bit different cases because it's more like the machinery issues, because they, in certain point, they lose their power controlling and all the power has been shut off. So even the emergency generators has been turned on, but there was too many gaps. So they couldn't do anything at all. I think it was more like a maintenance issues. So unfortunately, even though without power supply, we cannot help at all, but at least there might be a lot of like prevention things that adding on more like batteries that in cases of the cases can be handled. However, the Baltimore cases would be a little bit different, but For example, like a Suez Canal blockage, which was caused by the human error, and they didn't see the near side of the ship area that there's a heat at a certain level, so it blocks more than a week, then cost $1 billion to the economic damages. But in that cases, I think definitely our solution could assist in the situations, and they have been prevented any getting into hazardous area. So yes, I think that would be the answers of using our AI solutions.
On this specific case, we cannot answer because we have to wait also for the outcome of accident investigation to derive possible conclusions and benefit for the whole industry. But there are other incidents where it is evident that application of this kind of technologies will be very helpful. For instance, when you get on board a series of alarms that are perhaps exceeding the human capabilities to react, and the use of artificial intelligence or a sort of language knowledge-based can translate the alarm into an information that is easily understood by the people. So the benefit of applying this technology sometimes is to assume that people are humans, we are all humans, and try to convey an information that is the easiest for the humans to understand. And nowadays, with very complex system, it is not the benefit of having alarms bumping like that. And we have some incidents that have already been analyzed in a full accident investigation where we may take such a conclusion.
Thank you very much. So if can sieve out some learning here, actually what we are saying is that AI could augment human attention. So if we have sensors, as shown by Yong-Soo's presentation, we have solutions that is not totally replacing the human, but augmenting human attention. They might be alerted to some of these hazards ahead of time, and then we could react better, right? So it is actually a coexistence of AI augmenting human capability that could then bring very definite benefits quite immediately today. Okay, so for the next question, I think let's choose something that is perhaps on data. Since AI is contingent on usage of data, and there's this question about for common database toolkit, could the panelists share more about the process of driving consensus and infrastructure for hosting of data? Who hosts and who has the responsibility of keeping that up to date? So this is actually quite a common question on data ops and roles and responsibility. Any panelists would like to take this on? If not, let me try to perhaps get the ball rolling. From my perspective, I think about this problem around 3 T's. And the T's are trust, technology, and trade. So to drive consensus, often when we say, we need big data, we need many partners to share data, how do we encourage this? So fundamentally, trust has to be established between organizations. And when we talk about the concept of trust, it's not just trust between human and human, because at the technology level, there could be technology layers that could enhance trust. For example, using decentralized methods of AI learning, where data need not move from the owner's location to the central training location. So if technology affords, data could be decentralized, so owners do not feel the need of exposing their data to people, and then centralized training and centralized consolidation of the AI model. So technology actually has a way of influencing or enhancing trust. The other thing that often I think about is trade. So let me explain what I mean by trade. Because when we talk about data sharing, it is not a one-way process. Because often we think about sharing as giving. Often people who are giving data will ask, what do I get in return for contribution of the data? And in some cases, it might be as simple as, if you work with us, this work is actually funded by a program. As an outcome of the program, you will get the benefit of having further insights or access to AI models, but in exchange, you contribute a part of your data to the program. So in this sense, there is a trade. And in this context of trade, there is also a technology layer that we can think about. Now, the question is, what is the technology stack or technology layer that enhances trust and trade? The answer would be blockchain. So if we were able to add blockchain to AI, we could track and trace who is contributing data, how much of data is being contributed, and how much of that is being used to train an AI model, so that when there is benefit derived, perhaps, for example, in commercialization of some of these, we could then very quantifiably return the benefits to all the different partners that is actually that has contributed to this. So in this regard, that enhances the concept of trust. That also enhances the concept of trade. So if we think about trust, trade, and technology, all these three things work together. I think that would benefit data sharing quite a lot. Yeah. Eric?
Just to add to that, I think it's a very important point. Maybe one of the more important things to make autonomy scalable is to solve this thing. We see now autonomy projects popping up all over the world, and that is quite inefficient because autonomy is very difficult, and it will take much longer if everybody does it in parallel. And one of the key issues is actually sharing of data. So that's what we see with our investors as well, that the reason they invest in one company is because they want to have control of their own data, because the autonomy system will get a full insight into everything they do, and they don't want to share that with anyone. And then how do we overcome that? And that, what you just said, is the explanation of how to overcome that blocker for scaling autonomy across companies and industries and nations. Yeah.
Thank you, Eric. Yes, please, Roberto.
Oh, sorry for I will follow. I think it is important that we distinguish also the fact that raw data and ownership of raw data and what is the information derived from this data, that it comes from data analytics, where these tools can become helpful. So in terms of sharing of data, and considering how to trust the work done by these tools on analytics, it is important that it's not considered like a black box, but there is a way to understand what are the criteria behind that in order to trust the work being provided by these tools. Because otherwise, if you consider that a black box, probably you don't fully understand what is the value of information derived from the raw data.
Exactly. Hence, there is a lot of focus nowadays in the technology space about moving from a black box AI to a white box. I do not like the word white box AI. I would like to use the word glass box, because you can look into it, right, and understand what's happening. So Yongsu, last word from you before we end this session.
So as Eric mentioned, that autonomy requires tons of data to fulfill it. And also not just the raw data, it requires know-how, how to train this, and how to draw by human beings. But that would be one of the assets of the private company. However, acquiring raw data itself is still very difficult, because the shipping industry, it may take at least 2 weeks, maybe maximum 3 months to gather all the information. And it's very rare and unique industry. So not all the person can access to the services. So I would say maybe from the government or the international organization, maybe they can gather this, the raw data that are open sources. So every innovative company can access to this. I think that's the number one things. And as I've already mentioned, that the number two would be adding on the academic research labs or like the private company, open up the benchmark data. It may contain certain level of the know-hows, how to labels and how to train the things, but there might be a lot of competitions, and some will release a new, very innovative, like academical training methodologies, or how to label this and how to combine all different models into one. So I think that would be very needed in this industry. So maybe there's a lot of layers of the AI. It could be the language model, it could be the image recognition from the video, or it could be the LiDAR, any kind of the sensor things. But I think we should decide it, open up this benchmark data and try to compete globally to, take this autonomy into the every general agendas that everyone should discuss and access to this data.
Thank you. So open innovation is important. Okay, so with that, everyone, thank you for your attention. We would like to, with that, call the session to a close. Thank you.
Thank you, Dr. Suri, and distinguished presenters. Please stay on stage for a photo session. Let us kindly take a photo before. Let's pose for the photo. Thank you, presenters and moderator. May I invite you to return to your seats off stage.
Yes, just a second.